Hey, everybody. Uh-oh, looks like somebody just got kicked off the meeting. Not sure who that was, but hopefully they'll be back. All right, so when we ended last week, we were kind of just getting started into selection structure, so we have some more about those to talk about. You probably saw the announcement this morning. If not, one of the homework assignments, oh, there he is. One of the homework assignments from the selection structures, module 4, actually required loops. And I didn't realize that because on the old statewide course shell, before this semester, there was an assignment in selection structures that was that guess a number thing, and you get 3 tries. And then the following week when we covered loops, that same program was modified to give unlimited tries. But for some reason, when the new course shell was made, the version with loops is the one that made it in the selection structures homework. And I kind of overlooked that until I started grading some. It was like, wait, this isn't what I thought it was. So I did go back and change that. Some of y'all may not have even seen that yet, but I did change the instructions. So if you already did.
I'm sorry to interrupt. I thought you were going to finish. It's okay. I'll ask my question after you're done.
What was your question?
Well, since we're on the subject of these Raptor assignments, I was kind of confused because there's 2 very similar assignments, right? There's one where I think it's the 3 numbers, and I did one with a selection where I used the selection to do the Raptor thing. I think that's the one from the first of the Raptor assignments. It's like Raptor. I'm sorry, I won't go too far into that. But then the next one, it says to use a nested if statement. And I was kind of confused on that because I used an if statement on the first one.
We will be going over nesting this evening.
Oh, okay. All right, that's cool. All right.
That is like the second thing on the list I have here.
Okay.
Basically, nesting means to stick sort of like nested if structure. That would be put an if else structure inside of another if else structure.
If you could maybe just go over like how to do that in Raptor, that's probably all I need, because I understand how an if else is, like how that works. And I can do it in Python. That's pretty easy. But I was just like, it's confusing me in Raptor. Like the Raptor assignment asked for to do that, to create the flow chart using the nested if statement. Okay. Yeah, you get what I'm saying now. Yeah.
We will. I was going to go over examples of both as soon as we talk about it. So probably 15 minutes, maybe less.
There we go. Thank you.
Were there any other questions about the homework? So if you haven't seen it yet, the new instructions are there now, and I did go through the rest of them. It seemed like whoever put the course shell together really liked to ask questions before the material was covered. That seems to keep showing up. Do you have a question, William? Did you say something?
Yeah, it's not really about the previous homework. It's about the stuff coming up, module 5. I was in the discussion assignment, and your link for the secure computing seems to have a problem with that. So I just wanted to give you a heads up on that.
Thank you. I will make a note here and fix that link.
Apparently Michigan's not up to par on their links.
In module 5 discussion. Yeah,
secure computing.
Okay, that is security. Yeah. So if that link's bad, I'm sure that's a hot topic in technology these days. So I'm sure I can find another one pretty quickly. I will get that right after class this evening. Any other questions before we get started? Oh, I did have one more topic. One more quick note announcement, I guess. If there's no questions. Okay, yeah, it doesn't really affect much. There's a formality or technicality. I'm required to submit midterm grades, which don't really count for anything. I think sometimes if you're doing poorly in lots of classes, the advisor will contact you if the midterm grades don't look good, but they don't really count for anything. They don't show up on the GPA or transcript or anything. It's just a formality to report progress halfway through. And I have to do that at some point this weekend. So at some point between now and Thursday, I will just open up the grade book and write in whatever is there. But I think everybody is doing really well, except for the people that I have, a couple people that I haven't seen since the first night of class. They were here the first day and haven't heard anything from them since, but I think everybody else is doing really well in the class. So just gonna let y'all know that. You can see something about that, about midterms grades being reported. So let's see, check that off the list, check that off the list. Okay, so we were talking about selection structures, and there's a couple things that I wanted to talk about. The next step is kind of what Jacob was asking about just a moment ago. And there was something I was going to look at first, just because we ran out of time last week. But whenever we get to examples here in about 5 minutes, I'll get to that. Let's start with the idea of nesting. This is a term that you'll hear regularly with programming stuff. And basically it means to stick one of our structures for working with things inside of another one. So with an if structure, a very common one to do.
Who was that?
Is we'll have some sort of selection structure asking yes or no questions. So like if this condition is met, then we'll run some code, some bit of code, some lines of instructions. Else or otherwise, we'll do something different. So yes or no thing. This is what we were looking at the other day. We check some sort of mathematical condition that the computer can
We lost
determine.
picture there for a second.
Oh, is it back now?
Yeah, it's back.
Okay. Yeah, that's relying on Wi-Fi or relying on the internet can be a bit fuzzy at times. We have this selection structure where we can do one or the other things. Or in a flow chart, our symbol is going to be some sort of diamond, and we have a yes and a no branch. True or false, or if this is true, we'll take the yes branch. That's kind of like the first part when we do it text formatting. And if it's not, we'll take the no branch, and that's like the else part. But that'll give us a nice way to make decisions if we have a yes or no situation. Sometimes we want to know more than just yes or no. We might have multiple conditions. So a very common thing is to kind of nest these. I'm going to write some words in here. I'll just use Python syntax on this one. Do true stuff. Kind of fill that out a little. So if our condition is met, we'll do the stuff that's true, the yes answer to that question. But if it's not, we jump to the else part and we'll do something else. But maybe we have more than just a simple yes or no. A very common thing, and what I was going to use for an example to talk about this here in just a moment, is grades in the class, right? Because there we have quite a few conditions we want to check. Because if something is between 90 and 100, we'll get an A. If it's between 80 and 90, that's going to be a B. 70 to 80 is a C. So we have a whole lot of things to check. It's not just one yes or no. So a very, very common thing is that we check that first condition. If that's false, then we jump into the else block. And nesting is, once we're in that else portion, we'll put another if
My
statement.
phone? You call your cell phone?
So
Oh, the
here's
home
condition
phone.
number 2.
Okay.
Oh,
Love you.
I'm not sure who was talking. Somebody's not muted. There's a bunch of noise coming through.
I think it's Zachary. I don't think he's. muted.
Yeah.
Oh, can you mute real quick, Zach? There's a bunch of background noise. But so we ask one question, check our condition, do some stuff that is false. Then we can go in our else block, do two stuff, and put an entire another if else structure inside of that.
Wait.
And I'm going to run out of room on the board, but obviously that pattern can continue. If the second condition is not met, we can come down to this else structure and put another if else structure inside of the else here.
Can you only nest within the else structure? Or
we
can I
can-
do it within can I do it on the other side at the yes? Like, can I
Yes.
nest within that side? I can do it on both sides, right?
Yes, we can do it on both sides. I'm going to run out of room on the picture, but to do that in a flow chart, then it's kind of the same thing. So we have our yes branch, and then our no branch. We can just put another condition over here
Okay,
and have two branches there.
all right. All I
I ran
did
out of
was,
room, but we could just as easily do that here, right?
okay, so that's what they mean by nesting. What I was doing is I was just putting an output, right? I would only put an output, but what you're saying is to put another selection within the selection.
Yes.
Okay,
And we can keep doing that over and over again. We can put one over here. It comes
Okay.
out. And another
makes
one over here, and build up much more complicated decision making.
But
Oh.
we're doing like now, or is this whatever he was talking about, like ahead in?
This is on this week's homework. This where the instructions say use a nested structure. This is nesting. You can kind of see it in the picture. See how we took another one of these and just nested it right inside of there.
it's a Raptor, hold on, it's called basic or decisions in Raptor, and I think it's the second one in there. The second
And-
assignment thing.
Yeah. So it's one you will. It does pertain to this week's homework. So we can keep nesting those in there. It's kind of easy to see in the picture. This is something that happens a lot when programming, because obviously a one or the other thing isn't quite enough in most of our situations. So this happens over and over and over again, so much so that pretty much all of our programming languages have an abbreviation for this. So one thing we'll do, especially with Python, is we would have to keep indenting further and further over. And other languages where the white space doesn't matter so much, we typically indent it to make it easier to read. So we still have that. It keeps getting further and further indented as we go down, as we keep nesting more and more structures in there. So it's very, very common to abbreviate these and just kind of, I'll put a little arrow here. Move this if up by that else. So instead of if and then an else with an if nested in it, we'll have the word else if in most languages. Or two words, which does cause a problem in Python, because in Python, our white space matters. White space is significant, so we can't have a keyword that's actually two words long. So in Python, we abbreviate that ELIF. It's an
Hey,
abbreviation for
Zachary, your mic is still on. I can hear the music that is playing in the background or something.
I don't think he's bad at his computer. I'll get it. There we go. And when we do, it's just so common that way we don't have to keep indenting things. And it pretty much all of our programming languages have this, and we'll call it the if else if block. Or in Python, since we can't have a white space there, we call it if elif. Most people just say that, or depending on how you're saying it. So we just remove those letters and the white space and smash that together for the Python keyword. And then we can keep going down like that. So if, do something, if that's not true, else if, we do something else. And that is just a very common syntax for when we have multiple conditions to check to make a decision, something like this. But really it relates to the flow chart that looks like this. We have a true branch, but if it's false, then we'll check another condition. And if that one's true, we kind of come out of it. But if it's false, once again, we'll check another condition, and we can keep going like that. And that's the structure of the if, else if. I'll just
I have
put
a question.
dot. Yeah,
So every time you add a condition, you have to ask a question?
basically, yes. Until we
Okay.
get to the very last one. Because there's always two parts, right?
Right.
It's either true or false, yes or no. So eventually we will come back out to a no part altogether.
Okay.
Like on the flow chart, the very last branch. If none of these conditions are met as we go down through it, we'll come out a false branch or just a default setting. And same
Okay.
thing on these. We usually call that final else block. You'll often hear that as the default. I'll actually write that in there. So if none of the conditions are met, then we just have some sort of default that happens. Because a fallback to make sure everything's okay. Does that make sense, everybody?
Yes.
So, okay, and yeah, most of our languages does this, but one of the things Python did to make it easier for humans, the programmer, was they made white space matter, because as humans, that's how we separate things. We end an instruction with a line break instead of a special symbol, or we indent to show that it's a separate part. But because of that, we couldn't use the double keyword. We can't have a space in our keywords. So it's abbreviated in Python. And one other thing that kind of relates to this, I'm going to erase this over here because there wasn't much going on. We won't see it this semester because, well, between the flow charts, you can't really tell the difference, and Python doesn't have it. But all of these conditions I mentioned here, we've had those math conditions like we talked about last week, right? Greater than, less than, or the equality, and that's the big one that has its own separate thing. So if we're like, the value we're checking is more than some threshold, we'll do this stuff. Otherwise, we'll go down, well, like that one I just erased, and the example we're getting ready to look at here in a second to see this. If it's bigger than a 90, then the grade counts as an A. But if it's not bigger than a 90, then we check again. Otherwise, is the score that was entered bigger than a 80? And if it is, then the grade's a B, and kind of go all the way through our grades that way. But because of how machines work, equality can be treated differently than just bigger or smaller. There's some complicated things. I remember when we were doing 2's complement math a couple weeks ago, going through the examples, there was always that extra bit that I said we're just going to discard. Well, internally, when it gets to machine language, that extra bit is what's used to select a greater or less than. And equality, we can actually do a little bit differently. And in a lot of our programming languages, we have what's called a switch case. We'll switch on some value, and conceptually, it's almost exactly like an if, else if, else if, else if, else structure when we're thinking about it, where the difference is our condition can only be exact equality. It's exactly equal to a value in every single case. And the reason it's a separate thing is because in some languages that will be faster. We do not have it in Python because it wouldn't make Python faster, so they didn't even bother it. In some languages, they just threw it in there because it's a common thing, so people are used to working with it, so they just included the tool, and it's purely syntax. But in some of our languages, a switch case is faster because of how machines work. And we'll switch on some value, maybe we have something stored in this variable called X. I'm going to use curly braces to help indicate it's not a Python thing. And then we can check every case of what we expect X to be. So we could have like case of 1, and then do stuff. Case of 2, like X could be exactly equal to 1, or X could be exactly equal to 2. And then we do stuff, and so on and so forth, until we get down to the very last one. And we usually actually label that as the default case. And do stuff. Then I'll put a curly braces down here to, again, help indicate that this isn't available in Python, but I wanted to talk about it. It's exactly like the if, else if, else structures, but only for exact equality. And in many of our programming languages, it will be faster because of how machines work. So that's a very common one if you have exact equality. But for us, in this class, it's going to be the that first stuff I drew. I just wanted to mention switch cases. Sometimes it's faster, it's nice and organized, and it's like a row of flip. It really does become like a row of light switches. You can flip on and off. You just kind of go down there. So like if case 1, it would start checking these. If case 1 was true, then it would start running instructions, and it would keep running through all of them. So we do have to actually say when to stop running, when to break out of our structure with those. So it's like if X is storing a 1, we go through here, check case 1, run these instructions, and then break out means it'll jump past the end of this sort of selection structure. Or for another case that might make sense, instead of numbers, maybe we're checking for letters and we want to know about vowels. So we have like case A, and I'm definitely running out of room here. So like case A, E, I, O, and then finally case U. And then if any one of the letters that we're looking at is a vowel, so we'd run case A, then I'll try to write that in there so it makes it in the notes. A, E, I, O, U. Oops, sorry, I ran out of room, but imagine there's 3 more of these case structures here. So that if any one of those vowels is true, it's going to keep running stuff until it hits that break statement. So we don't have to put that in every single one. We can reorganize our stuff so that it will run a bunch of instructions based off what to happen as soon as one condition is true. But those who continue into programming, you will see those and get some practice with them. Oh, somebody's in the waiting room. I did not hear her come in. So we'll see that. We won't see that this semester, but those who continue in programming will see that. And again, it can be faster. We'll be doing mostly this stuff. Does anybody have any questions about the concepts there? That makes sense what nesting is? Okay. Hi, Macy. Sorry, I didn't hear a beeping sound, and then I looked at the screen and saw you were in the waiting room. I hope you weren't there for long.
Oh, no, that's fine.
Okay. Sorry. Yeah, sorry. I guess I didn't hear the beep. And
You're good.
so let's look at examples of how to do these in the 2 languages we're working in. So we're talking about nested selection structures, Macy, where we can make decisions with the computer and kind of do more than just a straight sequence with no variety. Instead of doing the same things every time, we can ask some yes or no questions and have some variety. I guess I'll look at Python first, or look at Raptor first. And Python's pretty easy, but it follows the same concepts. Most of our high-level programming languages go together in the same way. It's just slight differences in syntax. So for the example here, I'm going to use grades. Everybody's familiar with the grading scale, how that works, right? You take a quiz or something, you get some numerical score, and then that numerical score corresponds to a letter grade. That is what actually counts. So to have a computer do that, we would need to run a selection structure to do some sort of checking. So I guess I'll start with, I'll start with this one. We briefly mentioned this last week. We can call pre-built functions, and a good thing to always start with in Raptor is going to be to clear the console. That way we get any old stuff out of the way from over in the, any old outputs out of the way while we're debugging programs and making them work. So now to determine a grade, we would need to get a score. So I'll just set up a simple input for that. Input the score. And I'll put it someplace called score. Nice meaningful name for it. So we have that variable called score, storing whatever the user told us. So the first thing I want to check is something that we ran out of time for last week. So we didn't really get to say something. Is well, we're going to do math with it. I'm going to run this real quick. So obviously, right, if the user gives us a number, that's not a very good score. Like an 87, somebody got an 87 on a score, we get a number, we can do some math with it. Or in this case, determine that an 87 is a B. But what if the user gives us something that's not a number? Right? Like if the user enters yellow. We're not doing any math yet, so it's not necessarily going to crash. Yeah, but for the next steps, that wouldn't mean anything, right? So another thing we can do with selection structures is protect against bad input from a user. So before actually checking to see what that grade is, and almost all of our languages have pre-built methods for doing this, so that makes it a lot easier to check. We can just check and see if what the user gave us is a number, a numerical value for a score. And to do that, we have this pre-built function, is number, and I'll just start typing is, and you can see there's several down here. Like, is something an array or 2D array? Is something a character, a single letter? Is something a number, the one we're interested in? Is open, that has to do with graphics windows for making GUIs, graphical user interfaces. We're going to look at that quickly in week 6 just to see a couple key points about it conceptually. But we want to know if the graph window is open before we go try to do stuff on it. So that's an important one to check. Or is it a string? In our case, we can check if something is a number. You can see on the predictive box is number. And then in parentheses, it's expecting about a variable to be passed in. So I'll check is number score. Oh, yeah, I forgot the same thing again. I'll match the keyboard real quick and then get back to this. So the user gives us a number, and then instead of immediately trying to do something with it and the program crashes because we can't do math with the string or something, we can check and see if that's a number. We'll see better ones soon. But in this case, I'm just going to, for a trivial way to handle that, I'm going to go over here on the no thing. Well, if it's a number, then yeah, that's fine. We'll just move on past this block and then go into the next selection structure down here. But if it's not a number, we'll ask again for it. The score needs to be a numerical value. Please enter a numerical score. Oh. And then whatever they enter that second time will be score. Oh, I forgot quote marks. Thought I put them in there. There we go. Does that make sense? Oh, that one should be almost trivial, right? We can't really trust our users to give us a number just because we ask for a number. So it's very important to check that. And in this case, we'll just do it once. We'll see a better way to handle that next week. Actually, the expansion, when we talk about stuff next week, it'll be obvious how to handle that even better. But when the user gives us a number, we can make sure it's a number before we go do math with it, or ask them to give us something that's actually a number. And now down to the nesting structures. So we're talking about grades here, right? So I'm just going to use the scale from this class. A 90 or above is an A. 80 to just below 90 is a B. Anything that starts with an 80s is a B. Anything that starts or anything in the 70s is a C. The 60s are a D, and anything below that will be a failing grade. So if we start putting those conditions in, we might have to, your first thought might be to check both things, right? Check 90 to 100, or then check 80 to 90 and check both ends of it. But if we organize the way that it goes in carefully, our sequence of how we check, we can get by with the upper end. Because even if somebody gets extra credit, which I know has happened a number of times already in this class, like when I'm looking at the program for homework each week, if I see something that I really like, I'll hit +1 or +2 there on the score instead of -1 or -2 when there's a problem. So I'm really lax with grading, and whenever I see really nice stuff, I kind of give extra points, but it's not completely arbitrary, but it just kind of every once in a while I feel like doing that. But if somebody gets 103, they still got an A, right? We don't have to check to make sure the score is below 100. Anything bigger than 90, so we just check and see if score is going to be greater than or equal to 90. And then if it is, we'll assign a variable called grade, the letter A. That part should make sense, right? We confirm we have a number, so all of those in Raptor start with the word is, like just to check to make sure we have the right type of thing. Is it a number? If it's above 90, then they got an A. But what we saw last week was just yes or no, right? So if all we have is strictly yes or no, we can give them an A, or we'd have to pick one other grade. So to get more grades in there, we need to bring multiple selection structures in. I'm just going to drag it over here and put it inside that part of Raptor. And we could just as easily do this on the yes side if we wanted to rearrange the logic. I'm just going to do it on no because just to be consistent. And if we put it on the yes side, it'll start pushing things. Raptor will start pushing things over weird and rearranging things. And then we have to use the scroll bars a lot to mess with it. You will surely see that at some point. But for the example here, I'm just going to put it on the no side. And we can just stick it right in there. And in the flowchart, you can kind of see where that term nesting comes from. We nested a if-else structure inside of another if-else structure. If the score is not bigger than 90, well, then all we have to check is if the score is at least an 80. Because if it even makes it this far, we already know that it's smaller than 90. So the only things hitting here are smaller than 90. If it's smaller than 90 and more than 80, then we can go in and reassign the grade to set that grade variable to hold a B. And once again, it's a yes or no thing, so we only have one pass left to take, but there's still 3 more grades that could be assigned here. So we'll keep bringing in selection structures. And something I like to show, which this might be a good place to see that, is we can copy and paste as well. So notice if I click here, so I just click there on that condition where score equals 90, and it selected everything, including the stuff nested in there. So now if I hit Control C, or actually Control C, or so you all can see it, right click and go to copy, I can copy that nested part. So when you copy and paste in Raptor, you have to click where you want it to go. So left click where you want it to go, and then right click and paste it in that spot. So that gives us a way to bring in, so we can copy and paste all the nesting stuff too. Just notice if we click on the small one, it only selects that nested one. But if we click the one that's nested in, we get all that nesting included as well. So where were we on this pattern? Bigger than 80. So the next one, if it's bigger than 70, because if it hits here, we already know it's smaller than 80. Otherwise, it would have, if it was bigger than 80, it would have hit one of the yes statements already. So you want to be careful about how you organize those things too and minimize the conditions you put in there. So somewhere in the 70s is a C. If we still haven't found it, if the computer still hasn't found it when it passes 70, well, let's check and see if it's bigger than a 60. Is that not a good grade, but still passing technically. And then finally, we have another no. So we could check, we could put another condition here, but we're already all the way to our last grade. So that's going to be the default. If it's not any of those conditions we checked, then the default is, whoops, didn't mean to put a couple of those. Then the default will be a failing grade. Set grade equal to an F. And then we can just print that out. Does that make sense to everybody? Any questions about that? And we can keep nesting those any way we want. Figure out, use this big selection structure, which I might need to zoom out a little to see it. I guess I can see it there. We have this big selection structure where we check all the different conditions it could be. And if it's not any of those that we're mostly concerned with, then there's a default to fall back on. Usually I go the other way on the grading ones. I'm not sure why I started with an A. I usually start at the small end and go up. And that way I can use the sentence, the default is an A, because that sounds so much better than the default is failing grade. But when we go down, that's how it ended up. And then after we make all those selections, notice here in the flow chart, our arrows come back together and we're back to just a single pass again. So then we can output it. And so that student got us something plus whatever stored in that grade variable, I don't know, on the quiz, some meaningful sentence there. But output it somewhere. We've seen output since day 1 or 2 of the class. And then we can make more complex decisions. It's not complicated, it's not harder. We just do the same thing multiple times. So let's check something. If the score of, well, I want to check that input, right? We can't really trust users to give us a number just because we ask for a number. I'm gonna put some word in there which catches that thing. So it's like, oh, the score should be a number. So then we can enter a number, maybe a 97. And it should take the first branch and print an A on there. And then you always want to check all your values. So something in the 80s, so like an 83, it goes through there, gets that B branch. We check lots of different things. I don't know, I'm gonna try bad input as well. You want to check good and bad input to see what happens. So if they give us something that's not a number and that condition comes up and they give us something that's not a number again, it completely crashes the program. Next week, we will see a better way to do that to get around that. What's left to check? A couple branches left to check. Maybe a 73. And the first couple I checked were only integers. So remember to check floating point numbers. So 73.876, some decimal value. Make sure that works the same way. Looks like it hit the right spot. 2 things left to check. And remember, you always want to check thoroughly. So there's 67, which should be a D. It looks like all those conditions are working. 23.456. Okay, that was working. One thing that could be checked here, if we enter a score, what about something like a negative 45? That's a significant problem for like a quiz score, right?
Can I ask a quick stupid question?
What's that?
What is on the selections? You see that little, it's like a little minus right there. When you click it, it turns into a plus. No, like on the selection, you see right next to yes on selection. No,
Yes, that's a very common question. That's a collapse thing. So we can't really see it here, but down here where all those nested ones are, it collapses it, gets it out of the way.
Okay, I was like clicking and I'm like, this isn't doing anything. All right.
Yeah, yeah, the one up here we can't really see anything because there's nothing to collapse. I guess it does a little, but not much.
Okay, yeah.
And then
All right,
oh, no problem. That is a question I hear every semester. I probably should have pointed that, anticipated it. Because yeah, you can see that in the flow chart, it gets really big really quickly. So it can be useful to get that out of the way once a certain part works. But something like what I was just entering. If we entered negative 10, your quiz score was negative 10, that's an issue. Maybe you missed 10 points on a 100-point quiz, which should have been a 90, but it got reported as an F because it couldn't handle negative numbers. So that would be another condition we could check, just like we did this, just to make sure we have valid input. I'll put that up here. If score is bigger than 0, I guess we could have equal to, bigger than or equal to 0, because that's the lowest score we would get on a quiz, right? Don't have that taking points away from it. And if it's not, we could ask for another number again. Score needs to be positive. Enter a score bigger than 0. And whenever something like that happens, make sure you give nice descriptive things to the user so they'll know what went wrong and what to do. And we can check the input and make sure we're getting good input from the user before we go trying to do math with the numbers or try and, in this case, figure out what the letter grade is. Something like this week I have to report midterm grades. So get to the value that's reported at the middle of the semester or the end of the semester instead of the numerical value we track. And we'll end up with quite a few of those. And for the second thing we're going to do tonight after we take a break, we'll see a way to kind of abbreviate that some. But again, it's kind of only one position. But now that we've seen that, please try to work that into your programs. Whenever there's a spot where we're asking for user input, throw in a selection structure and make sure the user gives us some good input. Does anybody have any questions about that? Okay, so let's look at the same thing in Python. And we've seen a couple of different places to work in Python. If you want to, you can open up the Ripple IT site. I'm just going to do it here locally for this case because we haven't seen that yet. And I wanted to do it at least once, run it locally on my machine. So I'm just going to open a new text editor. Anything I need to keep? Nope. Get that out of the way. That was LaTeX. What was on the screen a second ago? That's typesetting. It's a markup language, which most of y'all will see those at some point. They're a little bit different. They're extra symbols we put into text files to bring up pre-built things. That's how web pages are built. That's where most of y'all will see it. But that particular one's a markup language for typesetting mathematics, so that we can type things and it looks like that nice formatted math stuff we do by hand or in math books, the square root symbols and stuff, because we don't have a square root symbol on the keyboard. Not a good way to type that. So that's what that was. But typing something in Python here, and I'm just going to do it locally here on the text editor. This is one that's on Windows machines, Notepad++. It's been popular for a while. It knows a lot of languages. I just scroll through the list. You can see there's programming languages for basically every letter of the alphabet here. There's only one G language. That's strange. It's not exactly strange. I know there's a reason for it. It has to do with C++. But we use the letter G in C++, so if we used it elsewhere, it would mess things up. You can see for pretty much almost every letter of the alphabet, there's a programming language that starts with that letter that this text editor already knows. So it can change colors for us and stuff. So I'm going to do the same program. Basically, yeah, I'll do the same program. I'm going to skip that second if block, and we'll just check to make sure it's a number, because I was doing that for a lead into something later. But I was hoping to take, get to the break in about 6 minutes from now. So we'll do the same example here, I guess. So like we just saw, we need to get a score from the user, and then we're going to check to see if that score is valid. So we're in Python, so we'll say this variable called score is going to be assigned some input from the user. Please enter a number. Please enter the score. And notice right now it's just black text. It's just basic text. Just because the computer, I haven't told the computer I'm writing in Python yet. But if I go ahead and go to save this file, I'll just hit Control S and go to my Scratch folder here, Documents, Delete folder. I'll just mash the keyboard. But the important part is I want the computer to know it's a Python file. So you're probably aware that whenever we save files, we always have that file extension, right? Like that Raptor file is .rap. When we have pictures, they're probably .jpg or .png, JPEGs or PNGs or GIFs. Or by default, if we just have text, it's going to try to save as .txt. That extension is completely arbitrary, but what it does is it tells the computer what type of file it is. Like it tells the computer what sort of programs to open that file with. So since I'm creating a Python script, which is just a text file, I could call it .txt and still run it exactly the same. You'll see here in a moment, because when I manually run it, I have to tell it, I have to include that instruction, that .py. But calling it .py, I'll give that a useful name. Gradebook.py tells the computer it's a Python script. And notice now, some of these things have changed colors. It recognized that this part's a string. I was expecting the word input to change colors as well, but that'll be okay. So we're going to get something from the user. We're going to be like, okay, give us a number. And then just like we saw a moment ago, it's a good idea to check if that is a number. So we can do that with a simple if-else structure like we were looking at last week. Is what the user gave us is either a number or it's not. And in Python, our notation for doing that is going to be the variable where we stored it and this is the first time we've seen it, we can use the dot operator in order to access things about that variable. There's a lot of information. When we store a variable, there's a lot of information there. And I guess is a good starting point. That builds into something huge. For now, let's say the dot tells us something about that reference we have, the thing we have stored in memory that we'll refer to by that variable name. And in this case, what we want to know is that a number? So we can type the word is numeric, I think. I don't need an underscore there, do I? Nope, no underscore. In most of our editors, words like is numeric will change colors. And then we've seen before, kind of like the input, that's a keyword that does something. And the way I like to summarize it is variables, which mean hold something, there's no parentheses. But if we want to do something, then we need parentheses. And checking to see if something is a number is doing something, so we need the parentheses. So we'll check that variable, the dot or something about the variable, and is that a number?
I have a question.
Yes.
Why is numeric like one word?
That's just the way they wrote Python. Most of the keywords in Python, so there's a really interesting story about when he wrote Python. I'll not get into too in depth right now, but he was, when he originally started creating Python, he wasn't taking it seriously. It was almost an excuse to get out of something else. So a lot of the original language for Python, that's how the guy that wrote his variables. He just put everything in lowercase letters and jammed the words together. So a lot of our keywords in Python are spelled that way.
Okay.
Which is just some of the syntax. Yeah. The week before Christmas in 1989, a programmer decided to spell it as numeric with no capital letters and no spaces, I guess would be the technical answer to that. And it's just still there. So if that is a number, then we're gonna go with that. What we're concerned about is if it's not a number. So if it is a number, this is something we've seen before, right? Things from the keyboard come in as strings. And we assume that it's just the symbolic language coming from the keyboard. So if it is a number, we need to turn it into a number. So if that string that came from the keyboard could be viewed as a number, then we're going to turn it into a floating point number. Oh, and notice the predictive stuff comes up again. Once I put that .py extension, the computer knows it's Python script, so it will predict stuff. It would also do that predictive thing where the words show up, but I turned that off because I use this for examples in class. But if you install Notepad++ on your computer, it would predict keywords. So things like is numeric, you would be able to just choose from a list instead of trying to memorize all those words. So if it is a number, but we're going to turn it into a floating point number and stick it right back in that same spot. But if it's not a number, we'll ask again. I'm going to copy and paste this one up here. Copy. And then in Python, again, our white space is significant. White space matters. So we indent all the instructions to show they're part of this else thing. Paste that with maybe a more useful message. The score needs to be a numerical value. Oh, whoops. Turn word wrap off. And see how it's that same thing we had before. That if else. We didn't do anything in Raptor because Raptor automatically converts between types, but Python doesn't. So before trying to turn it into a number, I went ahead and it's a good idea to make sure it's a number. So now that we've seen selection structures, you'll want to do things like that. Why is that still? Oh, okay. Hadn't typed yet. I was wondering why that thing was, the little collapse thing was still showing way down there. Okay, yeah. To your question earlier, Jacob, that symbol is the one we normally see in text editors if we want to get a bunch of code out of our way. Like if it starts to look really cluttered and we need to get some of that, clear some of it out of the way, we can just collapse it or fold it is a common term for that. So once
Yeah,
we have our number,
I guess I just
Sorry,
wasn't
what?
used to see. I guess I just didn't expect to see it in Raptor, but it makes a lot of sense now.
oh yeah, yeah, it's way more useful in Raptor because there's that huge picture that kind of gets in the way and we have to use scroll bars to navigate our way around. So they're way more useful than in the text file ones. Where was there? Oh yeah, now we can do that if structure. So the same thing we did before. Now that we have our score and we know it's a number, we can check and see if score is at least 90. Then our Python syntax is we have our condition, we end that keyword, the condition, then end that with a colon and indent the next line or indent all the instructions we want to carry out if that condition is met, which in this case, there is just the one thing, that grade equal to letter A. And then when we're done with the instructions for that true part, we'll come back out. And then we saw on the board, it's true or false. And in Raptor, that's what it was looking like. If, and then in the else part, in the else block, we have another if else in there. So check if score is at least 80, then we do the grade equals B. But that is one of the most common things we will see in programming. It happens all the time. So it's abbreviated. And in most languages, it's going to abbreviate it else if. But because white space matters in Python, we can't have that space there. We can't have two words for a keyword. So that's abbreviated elif. So if, then else if the score is at least 80, we'll set the grade equal to a B. And then that'll just continue. If it's not at least 80, it's at least 70, in which case the grade variable is going to be assigned the value C. So if score is at least 60, then grade be assigned to D. And if none of those conditions are met, then we get down to our default condition, which with that indenting, if we kept putting nested if else structures, and then each one's required to indent a little further in Python, we'd be halfway across this window by now with just a couple of things there. So that abbreviation is very common and is in pretty much every language that's been developed since the early 60s, 1962 or so. Every language that's come out since then, we will have that else if abbreviation, some form of that else if abbreviation. So if none of those conditions are met, then we drop down to our default one and then output our results. The student got a plus whatever stored in that grade variable plus on the test. And then that error message you all have probably seen a couple times before. You want to pay attention to what's stored in the variable, because if we had a number stored in grade, like if we tried to put score here, we get an error that says cannot concatenate string and integer. But we have a string stored there, so it's perfectly okay to concatenate that without casting it. So you want to pay attention to things like that. Any questions about that? Does that make sense? What's going on there? And now we need to run this script, right? So to run this, I'm going to open, just run it in the terminal. So I had Windows key X, Windows X brings up the list of these common things of the management functions, basically. The Windows operations, not software that's sitting on Windows. One of those being the command prompt, which you can see is underlined C there, so C to get command prompt. So Windows XC is a quick way to open a command prompt. And my computer is set up to know Python. You do have to kind of set things up, but I can just enter some keywords here. So over in the command prompt on Windows, I can say I want to run Python. Oh wait, I have to go to the right directory. So currently in the users Chris folder. Okay, we're gonna take a break here in just a moment. There was something in the chat room about needing to step away for a second. We're gonna take a break here as soon as this runs, basically. So I need to change the directory I'm working in because I saved that. I'll get Windows E, open File Explorer. I like to mention keyboard shortcuts because it's so much quicker to use a keyboard than a mouse. So the Windows key and the letter E is in Explorer or everything. We'll open this, and there's an address bar in File Explorer. So anytime we have an address bar, you should be able to hit Alt D, as in dog, or the second letter of address, to get to the address bar. And then I just type in the address documents, delete, because I know where I'm going. I just wanted to point it this way. But here's where I saved that Python file. So it's in on the C drive, the documents folder, the delete folder. So I need to navigate to that folder to work. So the command for that is CD for change directory. And from where I'm currently at, I'll type the whole thing. I'm on this computer in the C drive, the users folder, Chris folder for one of the users. In that, there's a documents folder, and that documents folder holds a delete folder. Oh, did I spell something wrong? Oh yeah, I did. Let me try that with spelling delete correctly. Okay, there we go. Now you can see on this little prompt that I'm in the folder where that's located at. Oh wait, that's a Linux command. I remember that I'm on Windows and not Linux. So you can see here, there's that gradebook.py file that we're running around. So I can just say run Python and gradebook.py. And we see that prompt, enter a score. So like a 93 should give us an A. And it runs through there, gives that. I'll hit up and run that same instruction again and check some of the other values. Like a 33.333333, something with a floating number. For some reason, it didn't register that as a number. Oh, so there's a little bit of an error there. We come back over here. Whenever it entered that if-else structure, when I forgot to cast the other, the new input into a number. Let me try that and run that again. Clear all that and Python, run the gradebook.py file. As again, the .py is for a computer. So since I'm doing it manually, I have to type all that in. Let's enter 33.3. It's not recognizing the decimals for some reason. I guess I might have used the one that only checks integers. Is numeric only checks for integers, I guess. I haven't been typing in Python lately, so it's not exactly fresh on my mind. But you can see as we go through here, we should be getting those same results. So enter some word, it's bad input, enter a number, and kind of getting the same results from that program. That's not the, I wanted to run it that way at least once to kind of point that out. We don't see it much anymore because we rely so much on graphical interfaces and clicking icons to make things happen. But anytime a piece of software runs, open that back up, Windows X and then C to get the command prompt. Anytime a piece of software runs on Windows, like when we go click on the Raptor icon to open up Raptor, it types those instructions in the background. So we don't see them getting typed in, but that is how all software still runs. Just in case you weren't familiar with that. So it can be a nice, quick way to get software testing going. But we also have the icons. If I go back over to File Explorer and double click on this, it'll kind of run for a second. Enter a score, if I enter a 78, it finished. The words popped up there for a second, but then it finished. There's different ways. If you want to keep that open, a standard practice in Python to keep things running when you do that, it's just ask for another input. Oops. Input, press any key to end. That last time, it hit that print statement, and then it was done with the program. So it just closed out the Python interpreter. So a common way, if you're want to run a Python script and it closes like that, the somewhat standard way to do it is just add an extra input at the end. That way there's one more instruction that is waiting on user input. Now if I double click to run that, we see our original prompt. So this is the Python interpreter. This is the software that actually runs line by line through the Python code whenever we just double click it to run it. If we enter some score, an 89, the student got a B, and then it pauses for a second. Press any key to hit the end of the script. Actually, the enter key. I don't know why I said the enter key, any key there. Press enter key to end, because it has to be actually receive that input, which you all have seen before happens when we hit the enter key. Anybody have any questions about nesting those structures? So you can see we can get a lot more details in our, we can ask much more complicated things. It's not strictly a yes or no. It still has to be in yes or no format, but we can have a list of yes or no things. Like in that case, is the score bigger than 90? No? Well, then is the score bigger than 80? Yes, then do some stuff, but no? Well, then is the score bigger than 70, and so on and so on. So we can ask a list of yes or no questions all at once and do some more complicated things. And after the break, we're going to look at ways that we can get more interesting conditions in here as well, if there's no questions about that. Okay, yeah, nesting is pretty straightforward, and we can do it in all our structures. We'll see it again with loops next week. So why don't we go ahead and take a 10-minute break? When I was getting prepared, I thought this was going to happen about 15 minutes ago. 10 minutes sound good to everybody?
Yeah.
All right, so I will see you all at 7:20. I'm going to go get a cup of coffee. I'm getting really thirsty here after talking for an hour straight. So I'll see you in a moment.